Welcome back. In this episode, we're going to be doing Constructs Part 2. We're going to be handling the integral types. We need to be able to have the virtual machine be able to handle integral types uint 8 through uint 64 and int 8 through int 64. So we're going to go ahead and write the code that makes that happen. We've already gotten ourselves set up so we can start actually making it work. Most of what we're going to be doing today is going to be copying and pasting. Let's go ahead and look at the code we're going to be writing today. So there's going to be a lot of it, but it's not going to be terribly complicated. A lot of it's going to be copying and pasting, and some stuff we're literally just going to be letting Visual Studio write the code for us. So it's not all that bad. Okay, so first we're going to, in the data types folder that we made last time, create a new class. And we're going to go ahead and call it integrals. There are several classes in this file, so if you want to split them up, you can. It's up to you. I just put them all in one place for simplicity's sake. Not necessarily readability, but simplicity's sake. Okay, if you look at the source code, you see stuff is in a certain order. It's there for logical purposes, but not the order in which they need to be written. So we're going to start with an abstract class called integral of t. Now, if you remember from last time, integral of t was, or I integral of t was written. So integral of t inherits from I integral of t. So it's just a generic. We're going to go ahead and let Visual Studio implement the interface for us, because we are going to need everything in here and not much else. We're going to need a protected t value and a protected smart pointer, which we'll just call PTR. For our get and set for both the value and the pointer, we will just get the value from the field that we just created. So we will get return value and set this dot value equals value. And same thing here, this is a get. So get return PTR. This address and length are the address and length in the pointer. So we can go ahead and say for these return ptr.address set ptr.address equals value. And same thing here with length. Okay, so for this, where is it in here? Here we go. For I integral.value, we're just going to return value. Actually, we're going to return the lowercase value. One less thing to put in the stack. Okay. We're going to skip over cast 2, both of them for the moment, and we're going to go over here to from and to binary. This is why this class is abstract. The from and to binary have to be different for each integral type. So we're going to make these abstract. And we're done there. Now, casting to and from. We're going to start with the one where we have, where it's a generic cast to T out. So first we need to, what we're going to be doing is we need to be able to cast from one integral type to another. So if you need to cast, for example, from an int 16 to an int 32, you need a way of doing that, and this is the way we're going to be doing that. So first we need to have a result that we're storing, which is going to be of T out, and then we're going to assign it to default of T out. Then we're going to get the value of the new byte. And its length is going to be the length of the result, which the result will know its own length. It just will. Okay, we'll be handling that in a few minutes. Okay, then we're going to be getting the binary value, binary representation of this integral that we're casting to another one. So we need to get the binary representation, which we could just get by saying to binary. Now we need to just copy the existing binary value into the value of we need to copy the existing binary value into the length. There are a variety of ways of doing this. The way we're going to be doing it is a little on the slow side, but it won't have any major issues. For example, we won't have to worry about overflows and stuff like that. The math just works out. So we're just going to do a simple for loop where I is the while I is the result dot length less than result dot length. And then if I is less than bin.length, copy bin.I to value.I. We're not going to worry about otherwise, because otherwise it will be 0 anyway, so that's what we want. Then we're going to take the value that we just had, which is in binary, and assign it to the result via from binary, and then return the result. Okay, so all that is all good. Now for the other cast 2, where we have an I integral as our output, what we're going to do is we're going to have an I integral result equals T out. Then we're literally just going to copy and paste the rest of it. And that's it. We have finished our integral of type T abstract class. The next thing we're going to be doing is we're going to be starting our integral types. This is where most of the copying and pasting is happening. So the first one we're going to be doing is we're going to do an int 8. We're going to put int 8 underscore t. That's an old C or C++ thing, but it will make it so C# doesn't lose its mind when it sees two different types of... Anyway, yeah, so we're going to be inheriting integral, and it's going to be of type sbyte. Okay, so the first thing we're going to be doing is we're going to make a constructor that takes an sbyte as its value and an address for the pointer. So we can say this.value equals value, and then ptr equals new smart pointer address, and the length is 1 because a int 8 is 1 byte long. And I keep doing this on accident. Okay, so anyway, now we can make a more simplified version that just takes the value and it can inherit this value, and the address can be 0. And we're going to make one more that does not take any arguments at all, inherits this, and returns its value is going to be 0. Okay, so now we have our 3 constructors. So once we have our 3 constructors, what we can do is we can implement abstract class. And we'll have toBinary overridden and fromBinary overridden. So fromBinary, the way this is going to work is we're going to check if the length of the value exceeds the pointer length, which is going to be 1. But we're going to want to be able to copy and paste as much of this as we can without having to work too hard. So if the length is greater than the pointer length, we want to throw a new index out of range exception. Then we're going to wrap the next part in an unchecked block. Unchecked keeps if there's an overflow, arithmetic overflow, it will ignore it. So if for some reason we wind up exceeding a value that normally it would not fit in, it just ignores it and we don't have to worry about it. We're going to handle our own checks, so we don't want to let it do checking for us because it'll cause issues. So now we just assign the value of the value to, and we want to cast it to an sbyte from the first byte. Okay, because we're getting a byte, we want to convert it to an sbyte so that it works. This is as simple as it gets, and that's why we're starting with this one. Well, other than uint 8. Uint 8 is a little bit simpler, but not by much. Okay, so, and then when we do a 2-byte, or 2-binary, we're also wrapping this in an unchecked, and returning a new byte array where the only thing in here is okay, what's going on here? Oh, return new. Okay, so we return a new byte array where the only value is the value converted back into a byte. We also have a couple other things in here that we need to do. One thing is we need to do a public static implicit operator sbyte. So we're going to want to be able to cast between an sbyte and byte. So what we want to do is we want to give it an int 8 value. We want an implicit cast to a uint 8, or not uint, int8 from sbyte. Return new int8. Int8. I typed that wrong. Int8t. So int8t value. Okay, so all this lets us do is if we're, let's say, down here, I'm going to get rid of that in a second. Okay, so let's say we're down here and we have a we have an int8t, and we want to just assign the value 100 to it. We can do that instead of having to say new 100. We could just do that. Also, what we could do is have an sbyte and just assign it straight from bar. So if we have an sbyte, we can assign it straight from a int8t, and if we have an int8t, we can assign it straight from an sbyte without jumping through hoops. That's why we have that in there. It's just a quick implicit cast operator. No big deal. Okay, so now that we have this class written, I'm going to collapse that and I'm going to collapse this one. I'm going to copy it, and we're going to make this a uint. So every instance of int8 needs to be turned into uint8. And instead of it being an sbyte, it's going to be a byte. We don't even need that cast. We don't need that cast. Okay. And that's the last one. Okay, now we have uint8 done. We just got rid of every instance. We replaced every instance of sbyte with byte, and every instance of uint8 we just put a u in, or every instance of int8 we put a u in front of. Okay, now it gets a little bit stickier because now we got to move on to int16 and uint16, and some of the code changes from here. Okay, so all of our 8s become 16s. Okay, and instead of it being derived from an sbyte, it's derived from an int16. Or short, if you prefer. It's up to you. I'm going to stick with int16 because I know what it is at a glance without having to think about it for half a second. Okay. So all of these are get turned into int16 or short. It's up to you, whichever one you want. So every instance of sbyte, this is going to have to be changed, so we're just going to get rid of that. Int16. There. Okay, so from binary and to binary are going to have to be changed here. And we're going to have one more we're going to have one more constructor added for each of these. So first we're going to do the constructor here. Int16t byte value. We're going to go ahead and let it inherit this because then it'll handle all of the pointer stuff we don't really want to do. Oh, by the way, change your pointer value, your pointer length here to 2. You want to do the same thing on your uint that we haven't done yet, but go ahead and do it now so you don't forget. Okay, so on your from binary, oh no, we're on the constructor. On the constructor, it's going to be from binary value. Okay, so this stays the same. In the unchecked, we can get rid of the unchecked block, and we're going to want to get the value. We're going to want a value we can store everything in, so we want a new byte, and the length is pointer.length. Although, in order to save a little bit of time, we're just going to change that to ptr.length. Okay, then we're going to want to copy the array. We're going to want to copy to value. Okay, this is supposed to be val. We're going to want to copy from value, this value, to val, the length of value. And then this dot value equals bit converter to int16 val 0. All right, so first we get the we make a new buffer that is the length of the value, which is going to be 2. Then we copy the value into that buffer of the correct length, and we then convert it to an int 16. Okay, so that's done. From binary or to binary is a piece of cake. We can get rid of this unchecked, and we just return bit converter to bytes or get bytes, and we just want to get it the value. So it's just a wrapper around bit converter pretty much at this point. Okay, so what we're going to do is the bulk of this is going to be the same here. There's no point in rewriting it when we just need to add use all over the place. All right, so uint16 is done, int16 is done. Yeah. Okay, now we got to do it again for int32. We're going to go ahead and just do the top one, and we're going to do int32, and then we'll do the uint32 afterwards. So int32. Okay, so for int32, everything is the same, including this. This just needs to be changed into int32. Like I said before, this is essentially just a lot of copy pasting. Here we're going to be adding U's in front of everything again. This is another reason why I prefer using, at least in this section, using U, int, and int, as opposed to short, U short, int, U int, and long and U long, and all that, because it's just a lot faster when, at least when you're doing the copy pasting bit. U int. Okay, we double check that I actually used, oh, I did not do this conversion. This needs to be U int. Actually, let's pull up the error list so that I can see when I make those kind of mistakes. Okay, last pair. We're going to copy this and paste it again. 64. Int 32, int. Okay. And lastly, turning all of these into uint. All right. Okay, so now we have all of our integral types done. The next thing that we need to do okay, all of our integral types are done. Let me collapse everything in here so I can see what I'm doing. All right, we have one last class we need to write, and I like sticking it up to the top. It's a static class called int. So public static class int with a capital I. And what this is going to do is going to save us a little bit of time on certain things. So if we want a uint8t, we just ask for a uint8. And we have one of these for each type. Int, 16, 16, 32, 32, 64. 64, 64. Get rid of the U's here, and 16, 16, 32, 32, 64, 64. Okay. Now, we're going to have a class in here which we can't write yet because, or a function in here we can't write yet because we don't yet have the type written. But we're going to be able to create pointers on the fly, not smart pointers, just regular dumb pointers on the fly. It's going to be a specific type. But we're going to go ahead and write the prototype in here already. And oh, no, I think we can actually go ahead and write this. Yeah, we can. Okay, so it's going to inherit where, or T is going to inherit iData type. And then we have T value equals activator, create instance of T. And then the address of value is going to be the address, and then we're going to return the value. So we can create a pointer of type T where we have the particular address, and then it just makes the pointer for us and returns it. Okay, last function we're going to have is going to be icky, but it's important. So what we need is to be able to return an integral that gives us the best fit for a particular integer. So we have an integral type. We know its size. We know whether or not it is signed. And we want a function that tells us, okay, what type do we need in order to make it fit properly? So this is just going to be a nice long if-then-else statement over and over and over again. So if the size is less than or equal to 1, and if it's signed, then we want to return an int 8, else return uint 8, else if size is less than or equal to 2, same thing here, but with int 16 and uint 16. Same thing here, except the size is 4, and this is 32. And once more, but the size is, oh, well, I can just say else here. And the value is, the size is 64. Okay, that's it. That's all of it. You've now finished writing all of your integral classes. There's a lot of them, but They're important. You cannot represent your integrals properly in binary in memory without these and then be able to interact with them properly. You have to jump through a lot more hoops otherwise. So this is the core that makes all of the data interaction work correctly. That's pretty much it. We're going to move on and work on actually putting the core of the virtual machine together next. See you then. One more thing before I let you go. It occurred to me that we forgot to change the length of each of the pointers, or each of the integral types, as we went. So down here, when we did the int32, this needs to be changed to 4. The uint32 needs to be changed to 4. Further down here, the int64 needs to be changed to 8. And the uint64 needs to be changed to 8. And yeah, there you go. Now it'll work right.